All right, guys, here we go. Review for test 28. First one says limit as x approaches 2 of x squared minus plus x minus 6 over x minus 2. Let's start out by factoring that thing. So I'm going to say the limit as x approaches 2 of x plus 3 times x minus 2 over x minus 2. Those would cancel, which leaves me the limit of only the x plus 3. And because that's a polynomial, you can just substitute the 2 in there. Get 2 plus 3 is 5. Number 2, limit as x approaches 0. Now, obviously, you can't just plug in 0 right there because it would make the denominator 0. So we have to work that thing out. So I'm going to cube that numerator right there. Remember how we did that. I'm going to go 2 cubed. 3 is, by the way, it's 1331. If you punch in 3cx on your calculator, 3 is next. The 2 will be squared. The h will be to the first power. Another 3. The 2 is the first power. The h is squared. And then I got an h cubed, and I got a minus 8 at the end over h. And I forgot to write my limit as h equals 0. So I'm going to simplify that stuff. On the top, limit as h equals 0. First of all, 2 cubed is 8. Those cancel. 3 times 2 squared is 12h. 3 times 2 is 6h squared plus h cubed over the h. Now I'm just going to divide, since I have an h everywhere, I'm going to divide everything by h and get 12, 6h, and h squared. And because that's a polynomial, I can just direct substitute, put 0 in. That would give me 12 plus 0 plus 0, which is 12. Number 3, another strategy. Again, I can't plug in that 7 because it would make the denominator 0, so I'm going to multiply by the conjugate of the numerator. Rationalizing here. But when I do that, I'm going to get limit as x approaches 7. On the top, I'm doing FL. I need to get x plus 2 minus 9 as my numerator. My denominator have the x minus 7. I wouldn't multiply that out. I would just leave it like it is. One thing I noticed about my numerator is really x minus 7. Cancel those out, which gives me the limit x approaches 7 of 1 over the square root of x plus 2 plus 3. Now I can break that up. The limit as x approaches 7 of 1 over the limit as x approaches 7 of square root of x plus 2 plus 3. And the limit of just 1 is 1. The denominator I can actually plug in is 7 now. So I get square root of 9 plus 3. Square root of 9 is 3. 3 plus 3 is 6. Get 1/6. Number 4, find this limit. This is absolute value. When you do absolute value, remember you got to take account of both cases. So I'm going to say x plus 4. I'm going to approach from the negative side, which means the absolute value would be the opposite of x plus 4. If I plug negative 4 in there, I get 0. Now I got to also do the right-hand side, so I'm going to approach negative 4 from the positive side. Now, if x plus 4 is positive and you take the absolute value of it, it's just x plus 4. If I plug negative 4 in there, I also get 0. Because I got 0 both times, the absolute value is, the limit is 0. Got the same number both times. Number 5, same type of problem, more absolute value. The limit as x approaches 2. Got to do this first on the negative side of x minus 2 over x minus 2. Because I'm going negative, the absolute value, if x minus 2 is negative, the absolute value is the opposite of x minus 2 over x minus 2. So I get negative 1. If I approach it from the positive side, what's going to change is the absolute value of x minus 2, if it's positive, is just x minus 2 over x minus 2, which is just positive 1. So because I got a negative 1 from the left side, positive 1 from the right side, it's a D and E. Number 6, find the limit of this piecewise. All right, so got to do the same thing. Got to go limit as x approaches 2 from the negative side. And if I'm coming from the negative side, I'm going to use the x minus 1. If I take the 2 and plug it in right there, I get 1. If I approach it from the right-hand side, the positive side, I got to use this one. I got to use that function, x squared minus 4x plus 6. If I plug the 2 in there, I will get 2 squared minus 4 times 2 plus 6, which is 2. And because I got a 1 and then I got a 2, that would not exist either. Number 7, find the equation of the tangent line. The equation, by the way, at the point 2, 2. So I'm going to say the limit as h approaches 0 of f of a plus h. Remember, a is your x coordinate, 2 plus h, minus f of 2, all over h. And here we go. Just gotta get through it. Okay, so f of 2 plus h means I'm plugging 2 plus h in. So I'm going to put 2 plus h in my numerator over 2 plus h minus 1. That's just plugging the 2 plus h in there. Then it says f of 2. Well, they've already done f of 2. It's just 2, and that's all over h. So I'm going to simplify my numerator, which means I'm going to multiply by the LCD, which is just this, 2 plus h minus 1, top and bottom. I'm going to have to take some space here. If I multiply that on my numerator, first of all, that would cancel. Just give me 2 plus h. And I would have 2 times 2 plus h minus 1. All that over h times 2 plus h minus 1. And now we just got to get through all the algebra. All right, so my numerator, I got 2 plus h minus 4 minus 2h plus 2 all over h, and 2 plus h minus 1. First thing I notice is 2 plus 2 is 4, 4 and the negative 4, that's gone. So my numerator is down to negative h. My denominator, I have h and 2 plus h minus 1. Those h's cancel. So I'm down to the limit as h goes to 0 of negative 1 over 2 plus h minus 1. I'm going to plug in a 0 right there. I get a negative 1 over 2 minus 1, which is 1. Negative 1. Now, all that work, that's just the slope. All right, so to find the equation, I'm going to do y minus the y coordinate, which is 2, using that point right there, equals slope times x minus the x coordinate. Still get negative x plus 2. Move that 2 over, get negative x plus 4. And there's the equation of the tangent line. That's awesome. All right, let's get number 8. Semi-quick. All right, same kind of problem, doing the same stuff. All right, so starting the same way, the limit as h approaches 0 of f of, I'm going to go ahead, it's a plus h. A is the x coordinate, negative 1 plus h, minus f of negative 1, which is 0, by the way, because it's right there, over h. I'm trying to save a couple of steps here. So let's plug in the negative 1 plus h both places. So I get negative 1 plus h plus negative 1 plus h squared. Now so that minus 0, and it's all over h. So let's do the math here. If I work all that stuff out on my numerator, we get negative 1 plus h. Now I'm going to square, multiply, double square. So square, multiply together, double, square. I don't need to write that minus 0 anymore. I'll leave that off. Simplify your numerator as much as you can. If I do that, the 1's cancel. I get h squared minus h over h. And because everything has an h, I'm just going to divide everything by h, which gives me h minus 1. Finally, now we got a polynomial. I could just plug in that 0, and if I do that, I get negative 1. There's my slope. There's my point up there, so I'm going to say y minus 0 is negative 1 times x minus negative 1, or x plus 1. So my equation of my tangent line is y equals negative x minus 1. That was fun. Number 9, if 8,000 vested compounded continuously, if the amount of 12 years. Okay, this is a straight up PERT, okay? So I'm going to go A equals P e to the RT power. And all he wants the final amount. The principal's 8,000. E, R is 0.07%. Time is 12. So I'm just going to punch that straight in my calculator. When I punch it in, I'm getting 18,530 and 94 cents. All right. Number 10, find a polynomial degree 4 with those zeros. What you need to do here is write them as factors first. So I'm going to put P of x is negative 4 came from x plus 4. Positive 4 came from x minus 4. Negative 2i came from x plus 2i. And also, if negative 2i is the answer, obviously so is positive 2i. So I'm going to go x minus 2i. And I'm going to go here. Those are conjugates and those are conjugates. So I'm going to do foo twice. So if I do FL on the first two, I get x squared minus 16. The second two, I get x squared minus 4i squared. So I can really have x squared minus 16 times x squared plus 4. And I'm just going to do FOIL there. So my final answer, P of x equals first. If I do outer inner at the same time, looks like 20x squared and last 64. Got it. Fastest changing if you can't tell. Number 11, last one. Graph that function, tell domain range and what the asymptote is. So first of all, I'm going to go ahead and draw the coordinate plane here. Usually the asymptote is the y-axis, but because of the -2, it's been shifted right 2. I'll draw a few coordinates there. So my asymptote is actually going through +2. There's the asymptote. The first point, remember, is always 1 to the right. And what I want to do for my second point is I want to make that parentheses be the same thing as the base. So the base is 3. In order for the parentheses to be 3, I got to use a 5 for x. So if I plug in 5, I get log 3, which is 1. So I plugged in 5, I got 1. So I'm going 1, 2, 3, 4, 5, up 1. There's my second point, and there's my graph. Hey, Casey. See, just got on the video right there. Got the door open. So domain, it goes from 2 to forever. It doesn't touch the 2, so it's a parentheses. The range is going up and down forever, and the asymptote is a vertical line that goes through 2. So there it is. Hope that's good with y'all. Come see me if you need me. Answer some questions tomorrow if you have them. Please come see me though. Hope it helps. Not many more left. See you, bye.